Hello, welcome back to another video. I'm just going to go over the sine rule quickly and just talk about a few things that you need to note and just go through a couple questions looking for both the side and the angle, so you can see there's a slightly different process between the two. So just get a nice heading up here. Sine rule. There we go. A bit of a smaller pen size, and we'll get right into it. So our formula for the sine rule is A over sine A is equivalent to B over sine B is equivalent to C over sine C. And these letters aren't just arbitrary letters, they correspond to a triangle, which I'll draw out here, where this angle is A, this is B, this is C, and your opposite side to the angle is the corresponding letter. And so you represent the angle with a capital version of the letter and the side with a lowercase version. So it's a very simple little breakdown. Just add some colors to make this a little more clear. And a nice blue for our bees. Alright, so now we've got a very colorful starting point. I just personally like the visual representation because the letters can get a bit confusing sometimes. So now we know green is our C, blue is our B, and orange is our A. And we're just going to keep that for the remainder of the video, just to make it nice and obvious. Okay, so getting into our first question, I'm just going to draw out a triangle here. Question 1, draw out a nice little triangle. Now, the nifty thing about the iPad is it doesn't matter how straight your lines are, because it straightens it for you. And actually, I'm just going to move this up a little bit. There we go. Now we're just going to label here, 21 degrees. 35 degrees. That's unknown degrees. We're looking for x, and this is 23. So if we come back up to this triangle, these actually look quite similar. And so we're just going to color them the same way. We get a green down in this corner and up over here. And we get a blue down in this corner and up over here. There we go. Now, if you look at the colors and the letters, we've said green is C. So we're going to plug that in. Accordingly, we get 23 is our lowercase over sine 35. And blue is our B. So we get x over sine 21. So this is the start of our working out over on this side. Now, just something to talk about. With the sine rule, you're figuring out whichever two you need. So you identify the 2 bits of information, or the 3 bits of information rather, that you have, and then you figure out from the formula which parts you're going to take. So obviously in this question, we're taking this section of the formula. We can actually completely disregard this A bit because it isn't relevant to our current question. So now we just do the working out for this. Calculators are very important for trigonometry because the sines and cosines and tans and everything are very difficult to work out unless it's a nice exact value. But for example, something like sine 21, we're going to need a calculator for. So if you're not like my girlfriend who lost hers and is now floundering around in math class, you should be alright. Hopefully you do bring a calculator, and we just plug this in nicely. But to start off, we're just going to do some working out. Get x on its own side, sine 21 times 23 over sine 35. So all I've done there is I've multiplied across this term, multiplied both sides by sine 21, and then the denominator on the left side disappears, and we move it to the right side. Just some basic algebra, and you can plug this whole term here, here's another color, this whole term here you can plug into your calculator, and should give you a value of approximately, let me put it in here, 14.4, and then just note that it's the 3 significant figures. Alright, so that's our question 1 finished. Not too complicated here. Now we're going to move on to question 2. Now question 2, I'm going to show a slightly different variation in which we actually find the angle instead of the side. So, draw out our triangle. Let's pick a nice new shape over here. Something like that should do. That looks very much like 90 degrees, but we're going to pretend it isn't. And just call it X. And 33 degrees. 25. 43. Now, you might notice I'm not using units for the measurements here. There's no particular reason for that. I just don't think it's necessary. But obviously, if you are using units, all you would do is add the unit on there. So for example, if this was meters, we just put meters here and add it onto the end of your answer when you get it. But just to make things simple rather. I'm not going to use units for now. We're not an exam, doesn't matter too much. And what I am going to do is just make this bigger over here. But I'm also going to rotate it just so you can take a look at this triangle over here, so we can pick our battles, so to speak. So what are we going to be doing? Well, if we look up here at this other triangle, we can color this the same way. This would be A, this would be A, and this would be C, and this would be C. There we go. So we've got our colors, and now that we've figured that out, I'm just going to rotate it back to make it easier to read. Just chuck it right about there. Now we put it into our formula. Now it's important to note when you're looking for the angle, rather than using this formula I've written up here, you actually use a formula which means the same thing. Sine C over C equals sine B over B. I'm running out of space here. Equals sine A over A. Alright, there we go. Now this middle bit isn't strictly true, so I'll erase that. But anyways, so we've got our two formulas. So we're using this one on the right this time. And we're using the A and C parts of it. So sine C, which is 33, over C, which is 25, is equivalent to sine A rather, which is X over 43. Now, you might see where this gets a little bit complicated, but we're just going to go through the easy step first, where we go multiply this 43 across to try break down the side with X on it. So we've got 43 times sine 33 over 25 is equivalent to sine X. And now, here's where it gets a little bit more complicated. When you're getting the sine across, you can't just divide it. You actually have to use arc sine, which usually is shift sine on the calculator, but it also depends on the model of calculator you have. But if you look for it, it looks like this. Sine -1. And then you put all this bit inside of it. Sine 33 over 25 equals X. And the value that should give us is I believe, around about 69.5 degrees. And I'm just going to say that 2, 3 significant figures once again. Now here's the thing. Over here, I actually didn't draw it very obviously, but this is an obtuse angle, right? Because if these two are acute, over here and here, then this would have to be obtuse. So we were looking for an obtuse angle, but we got an acute angle. Now this is the ambiguous rule, or the ambiguous case of the sine rule rather. And if you're looking for an angle that doesn't lie between the two sides, you're actually going to be able to make two triangles. So this is very important because often you'll have questions which have extra marks for finding the ambiguous case, and you'll miss out on those marks if you don't. So it's actually not very difficult at all. All you have to do is you grab this answer you got here, 69.5, and you subtract it from 180. 180 minus 69.5 equals 110.5 degrees, and we can just round. We'll just say 111 degrees. So what we've done here is we figured out the other triangle that actually works with the same value, and the reason this happens is because sine of x is equivalent to sine of 180 minus x. So if you put sine and you put either that 69.5 or this 111 within those sine brackets, you'll actually get the same value from it, which means obviously when you're working it out here, you're getting both values. But your calculator will only give you the one of them, and so that is how it works out. So that's something to be aware of. It's probably the only real tip and trick that I would say in sine rule, other than drawing out your diagrams very carefully. I use colors in this. You might not have them in a test, but just maybe label with the corresponding letters. A, C, C, just to let yourself know what you're actually plugging into that equation and where you're plugging into. That's around about it. I'll wrap it up there so I don't make it too long, and I hope that clears things up.